Today, we're diving into Google BigQuery. This is a piece of tech that completely flipped the script on data analytics. It took something that was slow, super complex, and really expensive and made it fast, simple, and, well, serverless. We're going to unpack how it made crunching insane amounts of data not just possible, but actually practical. So, to really set the stage here, let's just start with a wild question. How in the world do you query 1 trillion rows of data and get an answer back in seconds? Seriously. Before BigQuery, the answer was basically you don't. It's impossible. And that's the exact problem it was designed to solve. To really get why this was such a breakthrough, you have to understand the sheer scale of the problem. We're talking about the petabyte problem. And for anyone wondering, just 1 petabyte is enough data to store an HD video that runs 24/7 for over 13 years. Companies were literally drowning in data like this, and it was creating this massive bottleneck. Yeah, before tools like BigQuery came along, trying to work with these huge data sets was just a total nightmare. You had to buy and set up your own servers, the whole configuration was ridiculously complex, and even after all that, a single query to take hours, sometimes even days to finish. It was just a huge operational headache. And this slide just lays it out perfectly, right? On the left, you've got the old way, this constant, expensive battle with servers and infrastructure. And on the right, you have the BigQuery promise, all the power you could ever need with basically none of the operational pain. This wasn't just an improvement, it was a fundamental shift in how we think about data. So where did this game-changing idea even come from? Well, it turns out the solution was born inside the one company that was dealing with more data than pretty much anyone else on the planet, Google itself. And in 2010, Google decided to let the rest of us in on their secret. BigQuery was officially launched as a public service, and it quickly became a cornerstone of what we all now know as the Google Cloud Platform. Now here's the key thing. BigQuery wasn't some brand new, untested idea. It was actually the public version of a tool that had been battle-tested for years inside Google. It was called Dremel. So Google engineers had already been using this thing to analyze their own unbelievable amounts of data. They were basically giving the world access to their internal superpower. And they didn't just stop there. It started as this internal tool, Dremel, then went public, but then they kept pushing. They integrated AI with BigQuery ML, and later, they used Big Lake to connect the super organized data warehouse with all the messy, raw data you find in data lakes. It just shows that this thing is always evolving. Okay, so let's get into the how. How does this all work? It really all comes down to this massive architectural change that we call the serverless shift. The first piece of the puzzle is how BigQuery actually stores the data. See, instead of the traditional way of storing data in rows, it uses a columnar format. And think about it. When you're analyzing data, you almost never need every single piece of information for one record. Usually, you just need a few specific columns, but you need them from millions or even billions of rows. Storing data by column makes that specific action incredibly fast. And the second piece, which is probably the most revolutionary part, is that it's serverless. Now, that doesn't mean there are no servers. Of course there are. It just means you don't have to think about them. It's kind of like using the city's power grid instead of building your own power plant in the backyard. You just plug in, get all the power you need, and Google handles everything else behind the scenes. So, under the hood, there are really 3 key principles that make this magic happen. First, it's fully distributed across Google's massive global network. Second, it separates storage from compute, which is huge, because it means you can scale them and pay for them independently. And third, and this is the big one, it's highly parallelized. So what does that parallelization actually look like? Well, when you submit a regular old SQL query, BigQuery's engine acts like this brilliant project manager. It takes your big question, shatters it into thousands of tiny little tasks, sends those tasks out to be worked on all at once by thousands of machines, and then in seconds, it pulls all the answers back together for you. It's basically brute force computing, but perfected. But here's the thing. If you just think of BigQuery as a fast database, you're totally missing the bigger picture. Over the years, it's really grown into a full-blown analytics platform with some seriously powerful tools built right in. I mean, just look at this stuff. With BigQuery ML, you can literally build machine learning models using the SQL you already know. No Python needed. You can run what are called federated queries, which means you can analyze data sitting in a Google Sheet or in cloud storage without ever having to move it. It's also got incredible support for geospatial analysis and this super fast BI engine to make your dashboards fly. Now, of course, BigQuery isn't the only player in the game. You've got Amazon Redshift, which is known for its really deep integration with AWS, and you've got Snowflake, which is famous for its multi-cloud abilities. But BigQuery's unique calling card has always been that radical serverless simplicity paired with just mind-boggling scale. Okay, so this all sounds really impressive on paper, but why does it actually matter? Let's bring this all back down to earth and see how it's being used every single day to solve real problems. The use cases are just all over the map. You've got marketing teams crunching massive amounts of web data, engineers trying to make sense of IoT device signals, financial analysts building these super complex models, and even scientists doing cutting-edge healthcare research. The one thing that connects them all? They have a relentless need for speed and scale. And Google makes it pretty accessible with two main pricing models. You can go on demand, which is basically pay as you go, perfect if you're just doing some occasional analysis, or if you have really predictable, heavy workloads, you can go for a flat rate plan. That flexibility has been absolutely key to its wide adoption. So, what's the ultimate takeaway here? It's this. BigQuery gives you unbelievable speed and scale, but it does it by getting rid of that massive operational burden of managing all the infrastructure. It really did democratize high-performance data analytics, making it available to pretty much everyone. Which kind of leaves us with one last big thought. When the barriers to asking massive, complicated questions are just gone, and you can get answers back in seconds, what's the next big question you would dare to ask your data? The possibilities there are pretty exciting to think about.